No one? Okay. So why this is important? Because not only it will help to troubleshoot the authentication issues, it will also help you to understand the roaming part. Okay, so that's the reason I have to cover this part. Most of you were new to the session, though we had a discussion in the last session, but I'll still go through. And it's much more in-depth insight this time. So in security, wireless security, the protocol is 802.11i, and there are a few concepts. One is called authentication. So any client which is .11 compliant, it uses open authentication by default. Now, it operates at layer 1 and layer 2, and this is exchange, request, and the confirmation, where no real authentication happens. Now, some of you might be thinking, what does that mean, no real authentication happens? So it's very similar to you plugging an Ethernet cable on a wired network. Now, let's say you have plugged a cable with the laptop and the switch, but it's not necessary that the switch would be connected to the internet, and you can get the internet or IP or something, right? You're just plugged in, you're just connected. Similarly, its authentication is you're just connected to your access point with the SSID. Whether you are authenticated with the security or not, whether you have the access to the internet or not, that does not matter. So that stage happens, but a fully authenticated client is when it has crossed all the stages or the state machines. And then next one is encryption. So can anyone tell me where will authentication happen and where will encryption happen between client, AP, and controller? Okay, let's go through it first. The methods have been used for years with wireless, and there are two encryption methods. One is TKIP and one is AES CCNP. Have you heard about it?
No. No.
Okay. So that's an overview, or I'll say a 360-degree view of how it happens at the back end. Between the station and the access point, there are two modes. One is a beacon and one is a probe request. Okay. This was discussed last time in depth, so I'll not go in too much into this concept. Now, client sends the probe request, access point sends the probe response, and they get connected. Now, next stage comes authentication. So, client sends authentication request. If it's a valid one, EP will authenticate, or the controller will authenticate, I should say, and then they get associated. So just three stages: probe request response, authentication request response, association request response. Correct? And then it goes to connected stage. Did I mention here encryption? No. Any idea where encryption will fall in? Okay. So what's TKIP? So there are certain characteristics of TKIP. Now I'll go a little bit back in old days when there was another protocol called web. Now many of you who has more than maybe 10, 12 years experience and they have routers in your home, you used to configure a key, right? Somebody used to type your phone number, somebody will type just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But that was a very unsecured encryption method, and that's why it's obsolete now. So even in case you go through any documentation and you get a concept of web, don't spend too much time reading it. It's completely absolute. Even the TTP is now gone. Okay, it's just for the reference. So this was an enhancement on the basic security mechanism, and that web defined already. and web used to go for ARC4, or you can say ARC4. TKIP algorithms were the same as web. So that's the reason the hardware that used to encrypt or decrypt WEP can easily be upgraded to TKIP, right? But still it has weaknesses of RC4, and then hence it has been depreciated in WPA2. Now, what is WPA2? WPA2 is a key management protocol or technique. Just hold on to that. Then we have AES CCNP. It supports encryption length, key lengths that are 128, 198, and 256 bits. Most vendors that upgrade their chipsets now support extra processing needs, and this protocol led to the depreciation of TKIP. Why? Because it was much more enhanced technique, very difficult to crack. Okay, till now it's all good. So you read about authentication, you heard about encryption, but how to make them work together? Any idea? So now can anyone tell me where will encryption fall in between client AP and the controller? And where will authentication fall in? Try it out. As I said, there's no right and wrong answers. It's just your understanding at a certain level. That's it. No one? Okay. So when we talk about this call flow, your encryption will always be on the RF side between client and the access point, because that data is in air. Nobody is able to see this data, but hackers can easily log in and capture those data. That's why when you go to airports or any public place and you're with your office laptop, it's always recommended to go for a VPN setup, because you can compromise some confidential data or maybe your passwords. But when it comes to authentication, it happens either on the controller or on the AP or on the SSS level. So when I say these three entities, there are different scenarios. One is if you're using autonomous access point, then it will be taken care on the AP, but with a pre-shared key, the PSK or the passphrase. If you're talking about the controller who will do the authentication, there are again two modes. Either you're using PSK because keys are on controller itself configured, or you have configured radius server locally on the controller. But then we are left with very few options. It will not be able to support high-end authentication protocols. But when we talk about AAA, AAA will not support PSK, but it will support enterprise level security, which is .1x. So I'm just giving you a vague idea, and we are just building on to how the security works, how different jargons connect with each other, and how they make a complete framework. Any doubts so far?
No.
Charge up, guys. It's Saturday afternoon, not early morning. Show some enthusiasm. You were full of energy yesterday. Today, we have to do a lot of hard work. So, the thing that binds them together is called W, or Wi-Fi Protected Access, WPA. Okay, and this is a key management technique. So then, the pairing of authentication and encryption is defined with this certification, which is issued by Wi-Fi Alliance. It's an authority. And then there are three modes. One is WPA 1, or just normal WPA. Then we have WPA 2, and then we have WPA 3. So anyone who has heard about it? No one?
No.
Okay.
Yeah, yesterday we saw it when we were creating that one
Yes.
SSID. These options were available.
Correct. So good that you can relate. So we'll see that today, and we'll configure SSID again in your pods and see where these settings reside. So what are the characteristics of WPA? Now, WPA could operate on the current hardware for backward compatibility with web cards and hardware. WPA could use PSK or enterprise level authentication, and WPA was a temporary replacement for web, but has been depreciated in favor of WPA2 because now the latest hardwares, there are few who will not even support this, especially on the latest controllers. So what's WPA2 now? Who was the reason for depreciating WPA1? It offers A2.11i standard security, which was rectified. It's a standard which IEEE rectified from the security standpoint. Uses AES CCNP as an encryption technique. Uses PSK or enterprise authentication, and it adds protection for management frames also. So what do you mean by management frames? So when your AP and controller talk to each other, in order to validate that it's a friendly AP or the part of a network, there is an authentication which we can define on the management frames also. And I think I haven't got a chance to check your query, Kanti, for D. Good point. I'll check that. So maybe it was S or W standard. It's currently the most widely used encryption method. Now, if you see on your network, and if it's a PSK or maybe AES, then probably WPA2 would have been selected. Okay, so let's go back and have a quick overview. Anyone using pod 1 or pod 2?
Not using.